Okay, so calm down. So I gather Max visited you. Did you have a good time with Max? Yes. Does everyone have a good time with Max? Yes. Did he do anything like distribute chocolate or any of his other tricks? Money! Yeah, Max knows how to get your attention. Okay, so you've been all through the model of the long run and the short run, right? And yes, right? And you draw me U-shaped cost curves, and their marginal cost curves, and their average variable cost curves. And if you're given a price, you can find the profits box, right? Price equals marginal cost, price minus average cost times quantity is profits, yeah? And you can find the long run supply curve as the minimum point of the average cost curve, and you can tell the story for why that should be so. Then you've gotten everything you needed to get. Yeah, now she's asking. Yeah, you have a question? Yeah, ask it out loud. No one can benefit if you don't ask it out loud. No, they're not going to. They don't know something you also don't know, but they're not going to tell you. Maybe they will later. So we're going to move on from there. I see that somebody reminded you about the problem sets, or you wrote it down and did it yourself. Is there anyone who's caught short with the problem set? Everyone turned it in? Oh, okay, that's wonderful. I was prepared to say, it's all my fault. I should have told you a week ago. But if they're all turned in, I guess there's just nothing to say. That's even better. We're going to go, where are we going? We've done that. We're going to put that off until Tuesday, right? Because Thursday, a week from that, let's get our countdown right. November 6th, we're going to have our second quiz. So November 4th, I'll do a little bit of reviewing. Thursday, I'll still teach topics. I'll tell you when we're cut off, or you can tell me when that's far enough for the quiz. So I haven't gone over that review sheet yet. That's still from last year. That's certainly on the quiz, fixed costs, right, what you just did. And I will do surplus welfare in the environment in a few minutes. It's not a whole huge number of slides. So I'm pretty comfortable that we'll have enough time for that one as well. The allocating pollution between firms goes with the trading game, which you already did, right? You have a good time with the trading game? Yeah, all right, so you didn't have a bad week. I won't feel guilty. And that would be the kind of logical place to stop if we can get that far. If we don't get that far, well, we'll see. But I think we will. I think today we'll easily finish surplus, and we'll probably get allocating pollution before between firms started. Might get very far through it, and we may look at a couple of the other pieces that we have just floating around. Is that? They're hearing no objections. I will go on. So, also, I may have really bad jet lag. I'm 10 hours different from you. I got back yesterday. Okay, come on. Things stabilize. So today, we start. Let's see if I get us from the beginning. That's what I promised? Yeah. So we're going back to consumer surplus. We know surplus is a measure of consumer satisfaction. We'll review that for a second. Then we'll do the same sort of exercise for producers. And we'll get variable costs as the area under marginal cost. Then we have a form of the welfare theorem, which says competition maximizes surplus plus profits. That's the sense in which competition is good in this setting. Then we have the obvious, it's not true if you have an externality. Competition doesn't get you to the right answer. And we can show a couple of ways to get to optimality. In the simple model I have, you've already seen them. We can do it with a tax. We can do it with a quantity regulation. And we'll look at both, and then we'll be able to see where the money goes. So now we'll be able to take it one step further. We'll be able to see what's wrong with not taking account of pollution in the form of a deadweight loss, a new term. And we'll have a nice green box that you've seen before, which is money that goes one place or the other. And then we'll have a new triangle that will show what happens to profits as you do regulation. So that's the outline. Willingness to pay, you've done, right? We know willingness to pay is, I don't know if I can find a comfortable place to sit or stand today. I guess I'm just going to keep fooling with it. Willingness to pay is the area under the demand curve. And our argument for that was to take it one thing at a time. So we said the willingness to pay for the first unit was the price at the first unit. Willingness to pay for 2 units, price at the first plus price at the second, and so on. And if you add those up, it's an approximation of the area under the curve. Lower right on some to be precise. And here's the picture that goes with it, right? Here are my boxes. So if I wanted the willingness to pay for 3, I'd add the light blue, the reddish thing, and the dark blue, the areas of those together. That would give me an estimate of the area under that demand curve. Or I could use the trapezoid rule and say, man, hits at 70 on the top, and it's coming down at 3 to 40. 70 plus 40 is 110. Divide in half is 55. Multiply by 3 and divide by, multiply by 3. We're done. Yeah. So we could do that. Consumer surplus is defined, and we need this definition. Willingness to pay less amount paid. The amount paid is price times quantity. And we'll need that in a second. And here's the picture that goes with that, right? Here's our demand curve. Total willingness to pay is the 2 areas, the greenish and the pinkish. Amount paid is price. Here's my price. Times quantity is the greenish. Consumer surplus is the pink triangle. Been there. And one more diagram you've seen before. Willingness to pay for Q units, right, is the green. Willingness to pay for Q plus some more units, N, is green plus the pink. And so the willingness to pay for the N extra units is exactly this pink area. The area under the demand curve from Q to Q plus N. That'll allow us to ask if one point or another point is right. We'll be able to say, look, I have this point. Suppose I added a little. Suppose I subtracted a little. Now let's go and look at our definition of marginal cost. Definition of marginal cost is the cost of making Q plus 1 minus the cost of making Q. Yeah? So I could write down the cost of making 1 is the marginal cost of making 0 plus the cost of making 0. The cost of making 0 is defined as what? What's the cost you pay even if you make nothing? Fixed costs, right? It's just one of those definitions. So there I have fixed costs. I can do this again. I can iterate it. Cost of making 2 is the cost of making 1 plus the marginal cost evaluated at 1, right? And that means it's the marginal cost of 0 plus the marginal cost of 1 plus C. And cost of making Q is just this string, marginal cost of making 0 up to marginal cost of making Q minus 1 plus fixed costs. Variable cost is cost minus fixed cost. So variable cost is just this string of marginal costs. From the calculus, what have we done? What's marginal cost? Start out with a cost curve. How do I get marginal cost from the calculus? I take the derivative. Now, I have a function. I've taken its derivative. I find the area under the derivative. What do I get back? What? I have the integral, but what's the integral of the derivative? It's the function. That's the fundamental theorem of calculus. So that's all I've done here discretely, right? It's exactly the fundamental theorem of calculus. These are the derivatives. I've done discretely, though. And I add up all the derivatives. I find out the area. Notice I integrate the marginal cost curve, and I get back this. And if you're really clever with your calculus, you'll notice that I get back VC. And that's, I've taken care of my constant of integration, which would otherwise be fixed costs. Right? So there's no real magic there if you spent the year doing the calculus. You haven't. That's exactly how you prove your calculus theorem. And all you do to make it work is instead of approximating by a difference of 1, you approximate by a difference of 1 and then a half and then a quarter and then an eighth. Right? You get finer approximations, you actually get the same answer. So we now know the area under the marginal cost curve is variable cost. And in a minute, we'll take that to our diagram. So here's marginal cost. Here's the area under marginal cost. So variable cost of 3 is approximately 1 times the marginal cost of 0 plus 1 times the marginal cost of 1 plus 1 times the marginal cost of 2. Or if you wanted to, if you had something like that, you could simply draw up to MC of 3, draw down, and cross and shade in the whole thing. That's perfectly good for our purposes. And if this thing had a little bit of curvature to it, and you wanted to calculate it, and you wanted to say, it's approximately this plus this height divided by 2, right, times the width, that'll work for us too. Just say what you did. But the truth is, variable cost is the area under marginal cost. Now, obviously, it's a function of Q. So here's variable cost of Q is the pink. Variable cost of Q plus N is the pink plus the gray, whatever color that thing is. And so the additional cost of going from Q to Q plus N is just this grayish area. That's exactly like the other one we did, right? We just did one with the demand curve, and it was the area under the demand curve from Q to Q plus N, and now it's the area under marginal cost from Q to Q plus N. And here's one last piece of preliminary. What about profits? Well, on these diagrams, I can't tell you anything at all about fixed cost. But let's see what I can tell you. I can tell you profit is price times quantity. Price is the height up to the black line. Quantity is out to here. This makes sense. Price equals marginal cost at this point. That's how we determine the quantity. Right? So price times quantity is revenue. It's both colors. Now I happen to know variable cost now. Variable cost is the brown. So revenue minus variable cost is the green. It's not quite profits. It differs from profits by fixed cost, but don't show up on the diagram. So we're likely to just say, let's suppose there's no fixed cost and kick it under the table. But if you prefer a different answer, you could say that the proper title for this green area is quasi-rent. And I will not ask you as a quiz bit what is quasi-rent, I promise. So revenue minus variable cost is the green. Now we come to the question of what good thing does a competitive system do? This is one form of what we call the first welfare theorem. And what we're going to claim, and we'll show in a graph in a minute, is that competition, that's where supply equals demand, right, maximizes the sum of consumer surplus and firm profit. I will show you in a second that that's equivalent to maximizing willingness to pay minus costs. So let's just do that. Willingness to pay is, or read it the other way, surplus is willingness to pay minus price times amount paid, price times quantity, or willingness is surplus plus revenue. Yeah? Profit is revenue minus cost, or cost is revenue minus profit. If you're doing these slides, these are not minus signs. Do something. Turn them into something else. Turn them into happy faces or something. I should really get back in the slides and manage to not have them as the dividers. So if I just subtract, I get willingness minus cost equals surplus plus PQ minus PQ. So PQs go away, plus profit. So I get willingness minus cost is surplus plus profit. So the two things are the same. So competition does, what we'll show, does both. It maximizes surplus and profits, which is the same as it maximizes willingness minus costs. And now we have a proof by picture. I like proof by picture. Here I have marginal cost, which I take to be the supply curve of one firm. Or if you like to think of it that way, it could be long-run marginal cost. I don't care what variety of marginal cost you think of it as, but it is what gives the supply curve that goes along with that demand curve. And here I have a demand curve. And since that is the marginal cost of the supply curve, supply equals demand, gives me the quantity in equilibrium. And it also gives me the price if I brought it back here. The pink quadrilateral is willingness to pay. The grayish area is the area under marginal cost, so it's variable cost. So the pink area, pink triangle that's left, is willingness minus variable costs. Yeah? Now I'd like to try a couple of other points. This is another three bears proof. Right? There are only 3 points. The one Q star, a quantity bigger than Q star, and a quantity smaller than Q star. Those are the only 3 points. So I can go check out what happens to willingness minus variable costs with different quantities. I'm going to show you that willingness minus variable cost is biggest here. And if willingness minus variable cost is biggest, willingness minus variable cost minus fixed costs is biggest, right? Because when I take off the fixed cost, I'm taking a fixed amount from all 3 cases. And so if this is the biggest one and it gives up, I don't know, a fist's worth of of fixed costs. When I get the next one, it too will have to give that up. When I get the third example, it too will give it up. So whichever maximizes willingness minus variable costs also maximizes willingness minus variable costs minus fixed costs. That okay? Or do I have to write that? All right, that's accepted. No? Yeah, so you just have some maximization problem. You have three cases, right? You have Q star, you have Q little, and you have Q big, for argument's sake. And this one has this triangle, and I'll show you in a minute Q little has a smaller triangle, okay? And Q big has this triangle plus a little negative triangle, right? That's the three cases that you can see. And the triangles that we have are all, what are they all? Willingness, which I'll call W, minus variable costs. And this one's going to be the biggest, it'll turn out. Now, what happens when I subtract from each of these some amount of fixed cost? Now, remember, the fixed costs are the same in all three cases. So if this is the biggest, then this minus a fixed number is still bigger than that minus the same fixed number. Yeah? So I can also subtract, just take this fixed cost out too. Whichever one's biggest without the fixed cost is also biggest with the fixed costs, because all three cases have the same fixed costs. Okay, was that an okay answer? It's a kind of sheepish smile. I think I'll get a question on this later from you. That would be okay. So let's go for a smaller Q. Here's my Q star, right? Here's the original. Here's a smaller Q. Here's Q little. What happens? Well, what are my variable costs? I'm sorry, what's my willingness to pay? My willingness to pay is the red area now, right? The area under the demand curve up to Q. And what are the costs? The costs are now the blue area. And so willingness minus costs are just the remaining red area. They're the snub-nosed trapezoid. And what got lost was this green triangle. So by making too little, making less than the equilibrium amount, the green triangle is the measure of how much willingness minus costs were given up. That green is by how much we are wrong. And again, if you look on my board for a second, which is not wonderful for those looking a second time, I draw on the triangle, and here I draw on the triangle with just its snub nose. And the piece that's missing is the green. So that's how much you give up by making too little. So clearly Q star is better than Q. It's better by the green triangle. What happens with a larger Q? So for a larger Q, I'm going to use what happens when you make a little more. So now if I go from Q star to Q and make a little more, what are my additional variable costs? Additional variable costs are the area under marginal cost, which gives you the red trapezoid. What are the additional benefits? The additional benefits is the area under demand. This is a dark blue from Q star to Q. Right? Which is bigger, the costs or the benefits of making those additional n units? Which one's bigger? Just bigger area. The costs, right? This cost curve is above, the marginal cost curve is above the demand curve. So this red is a negative, the red triangle is a negative area. So the total willingness to pay minus cost is plus the big blue triangle minus the red triangle. So now again, we know Q big is worse than Q star. We know exactly by how much, the red triangle. So we now also know that if I know the right output, here it's the competitive output, if I know the right output, and I choose any other output, I will have a measure of how bad that new output is. And it will be a triangle. And that triangle gets a special name. It's called deadweight loss. Well, before we go there, let's think about deadweight loss. That's a funny name. It starts out with the deadweight loss of taxation. And maybe we'll draw that on a slide or on the board before we get done. And what's the idea? The idea is, in taxation, you're taking money from one person, giving it to the government, and doing something useful with it, we'll say. But in order to do that, you have to make the wrong quantity, yeah? Because you have a demand curve and a supply curve, and you put on, and they're upward sloping and downward sloping, you put on a tax, what happens to the quantity? Where does it go? Back to the first day of class. Back to a long problem set. What happens to the quantity when there's a tax? It goes down, does it not? And so if it goes down, then you have exactly the case we looked at. Oops, let's go back 2 cases. Yeah, that's far enough. Right? This is the case. Here's the competitive quantity. Here's a lower quantity. How did I get there? Well, the story I just told you, there was a tax. If there was a tax, what would happen? I'm going to try to draw on top of this. Okay, so what would happen? You'd shift the demand curve down. It's hard to see, but there it is, by the amount of the tax, right? It's a standard story. And if you did that, and I drew it correctly, I should have drawn it through here. There we go. That's better. A little bigger tax does it. Yep. That would give me the new lower quantity. And like I said before, if this is the equilibrium quantity that maximizes social welfare, and you have a program that gives you a smaller quantity, then you will have a deadweight loss, in this case, in the green area.